is the amount of heat it takes for 1 gram of a substance to increase its temperature by 1 degree. And again, things like water, they have high heat capacity, but all metals have low heat capacity. So think about when you're cooking, right? If you use a metal container, you use a metal spoon or a metal dish, anything that's metal, it heats up a lot, right? Whereas if you're using let's say silicone or wood, it doesn't heat up a lot. And that's why you use wooden spoons when you're mixing and stirring something, because when you use a metal spoon, then the spoon gets really hot. Yes?
How come the wooden spoon also gets hot, right?
Not as hot though.
Okay.
Right? Yes.
Wouldn't heat capacity be different if you're looking for Kelvin or Celsius?
I'm going to show you the units in a minute. But the change in temperature is the same whether it's Kelvin or Celsius. It's delta T we care about, right? So we're going to look at the units.
Why are there so many deltas? There's delta H, delta T.
Okay. So let's look at the units here. Joules per gram degree Celsius is same as joule per gram degree really Kelvin, not degree. But why is it the same? Because you're looking at per degree. It goes up by 1. So 273 Kelvin versus 274 Kelvin is the same as 0 versus 1 in terms of the change in temperature.
Cool.
Since we're looking for delta T in these problems, which we're going to see in a minute, it doesn't matter if you're using Kelvin or Celsius, as long as you're obviously using the same unit that, TF minus TI. It can also be in calories per gram degree Celsius or calories per gram degree Kelvin. Heat capacity, the specific heat capacity is specific for the substance. Like water's heat capacity doesn't change. Liquid water has a heat capacity of 4.184. That's always the case. Okay, but ice has less. Okay, so let's think about a specific heat capacity here. You're at the beach, right? It's August and your feet burn when you're on the sand, but when you get in the water, you're freezing. Why?
Because your body temperature is lower than the
sensory adaptation.
You think about sand versus water. Which one do you think has a higher heat capacity?
I mean, the
water.
Water, right? Because it takes a long time for that water to get hot, but that sand gets very hot very fast.
Is that
right?
because it's made out of rocks and metals?
Sand's main ingredient is silicon dioxide, SiO2.
But isn't that rock?
No, not necessarily.
Well, then how come in elementary school they're like, sand is made out of crushed up rock?
Yeah.
Well, yes, but
I watched a video about how that happened.
right. It was rock, and then it broke down, right? It eroded, yeah.
That's pretty cool.
So,
in elementary school, we did a play called Geology Rocks. Why was your elementary school so wrong?
all right. So, higher specific heat means that substance takes longer to heat up and longer to cool down. We've talked about it takes a lot of energy for water to heat up, right?
Yeah.
And that's why it's a good thing, because the bodies of water, when you live by the beach, right, the temperature is a lot more moderate than in the valley. Why? Because there's a lot more water, obviously, surrounding you, which means the heat is taken up by the water, and since water has such high specific heat, the surrounding area doesn't heat up as much. So if it's 110 degrees in the valley, it's like 85 at the beaches, right? Because all that heat is right here in the water, right? And at night, what happens?
Really cool.
Well, there's a lot of heat now in the water that it absorbed. So that heat is going to be released. So at night, the temperature is a lot more moderate. It doesn't dip as much as it does in the valley. So in the valley, you might have a 40-degree difference between, during the day, 110, it does happen, and it can drop to 70 at night. At the beaches, if it's 85 during the day, it's probably 70 at night. right?
Mhm.
So think about that. It's a 15 degree versus a 40, and that's all because of all this water, and that's why it's so much more expensive to live at the beach.
Do you
Because
burn
it's
it?
just better.
Do you burn a
No,
lot?
it's better. Well, it's better. It's better
temperature.
temperature. That's really what it has come down
Like
to.
right now in Santa Monica, high 63, low at 55.
And
Yeah,
that's
that's
why we
it.
live by the
Do
beach.
you burn a lot,
That's why I
like
live by the
easily, more easily when you're in the water? Because
Yeah.
There's more reflection. Yeah. All right. So now, if you do a comparison of actual values, like if you look at actual numbers, the specific heat, this capital C, by the way, is specific heat. Specific heat of water is 4.184. So it takes 4.184 joules to heat up 1 gram of water by 1 degree Celsius, but it takes 0.664 joules to heat up 1 gram of sand by 1 degree. So that's a big difference, right? That's why the sand gets so hot, whereas the water doesn't. Okay? Did you have a question?
Why is like the water in like hot places still very cool?
Well, it depends on how much energy it absorbs in what area, right?
Like
It kind of has to mix in together.
Like in LA, it's always super hot, but the water's like very
In the Mediterranean, the water's warmer. Why is it?
It's warmer because I don't think it's.
Is it a sea and not an ocean? Is that why?
Yeah, it is a sea.
What does that mean?
It means that it's not
It's
like
a smaller body of water.
technically the
And
Strait of
ocean.
Gibraltar. Actually,
Yeah, the ocean is always cold.
wait, is the Strait of Gibraltar the one that's like connecting the?
No, okay. All right. We're okay. We got.
Mister, I heard the other day about a thing that there was an idea at one point for them to dam the entire Mediterranean Sea so that countries would stop fighting over land and they would just have more land.
Humans are crazy.
Then we would have just lost like so many animals and like they wouldn't have food, you know.
No. There'd be
The
no way for them
Mediterranean
to
Sea,
get
it's a port, right?
Okay,
Can't do
so
that.
we're going to.
Oh, this looks like last year mistake.
Wonderful people.
Oh,
I just need a few more minutes of your attention. So, this is the formula we need. And this is why we didn't do the lab today, because unless we know how to use this formula, we can't do the lab. So Q equals MC delta T, where M is mass in grams, C is specific heat, and that's specific to the substance we're dealing with, and delta T is TF minus TI, final temperature minus initial. Okay, now all units have to match up. What that means is you have to make sure your mass is in grams. You have to make sure your heat is in, if specific heat is in joules, you have to make sure your Q is going to be in joules, right? So again, if you're dealing with Kelvin, then you use the specific heat that's given to you in Kelvin. Otherwise, you use the degrees Celsius, or you can always convert. But delta T comes out to be the same whether I'm dealing with degrees Celsius or Kelvin. So now we're going to do this practice problem. And
Yay.
once we're done with that, then we're going to be done for today. Okay, here we go. How much heat is given off by a 75 gram sample of pure aluminum when it cools from 85 degrees Celsius to 46.7, and aluminum's specific heat is 0.899 joules per gram degree Celsius. So I want you to do what you did with the gas laws, given formula and solution. So these are 3-column problems again. Once you solve that, we go over it. I check your work with mine, and we call it a day.
Solution. Line. Okay, so Q. Okay, what's Q again?
heat, so in calories, or joules. Wait,
Alright, list the given, put the formula.
Wait, can you go
Plug
back
in.
to the last slide? I need to know like all the
The what?
all of like the what Q equals.
Or what they need to be in.
No, like
Q is joules, right? Q is your heat energy. It's heat, it's energy. It's same as enthalpy. M is in mass in grams. C is specific heat, and specific heat has a bunch of units, right? Because it's the amount of energy per gram degree Celsius. And then T is temperature.
so
By the way, that T should never be lowercase. That's wrong. Delta T, the T should always be capital. Lowercase t is time.
wait, so Q
There's
is
a typo on this.
75 grams.
M is 75 grams. 75 grams. Mass. Evan, mass is what?
Grams.
Okay. Huh?
You're looking for Q.
You're looking for Q. That's heat.
So that minus that equals
That minus that? What's
84
that minus
minus
that?
46 equals the temperature.
TF minus TI. TF minus TI.
Oh, so
TF.
it can be negative.
Ugh.
No, I'm sorry.
Have you guys been listening to me?
Yeah, I know. You
Negative
said that
means
doesn't
what?
mean negative.
Losing 37.
Exothermic.
Right.
Release of heat.
Delta T is equals from something. So delta T is 84 minus 70, 46.7.
No. This is this. No, if you're given this.
It's not.
Nathan, can I borrow a calculator?
Just give it a sec. It's waking up. It's okay. Had a bit of a nap. It's 44. Yes. Or 43.
What?
It's a good letter.
Do we calculate?
So what did you get for delta T? I got that it's 37.3.
I think I got it, but I also don't know.
What did you get?
2,514.
Positive or negative?
Negative.
Yep. Whenever it says how much heat is given off, you know you're dealing with an exothermic problem, right? And you know that because when you look at TF and TI, TF minus TI is negative because final temperature is 46.7, initial is 84. So you end up with a negative there, and because you end up with a negative, then you end up with a negative at the end, right? And so when you plug in Q equals MC, make sure you do capital T, please.
Oh, it's because you're
And so
doing.
you do 75, right, times 0.899
You're subtracting.
times 46.7 minus 84.
Oh, it's the wrong thing. I did it wrong.
Right? And what do you end up with? 2,000 what?
2,514.95.
So let's just do 2,515 joules. If you wanted to convert this to kilojoules, it would be 2.515 kilojoules. Just so you know, the conversion is 1,000.
Wait, so you're not write it negative?
It is negative. Sorry, I missed them.
Negative 2,000.
Yeah, got it.
17.
All right, we're calling it a day.
It has to be in joules. We're not doing kilojoules.